Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of attributes of quadratic function graphs. This is standard A.7a in the great state of Texas, and we are using item number 29 of the 2018 released STAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find the graph that best represents a quadratic function that has only one zero. Now, if we don't know what this term means, we are in a lot of trouble. So let's see what we notice about these graphs, and we'll see if any of those help us with trying to figure out what that word zero means. It's not going to be on your mathematics chart or your reference materials. Well, for most of these graphs, we can tell the vertex. I'm going to put that as a V. We can tell the x-intercepts. We can tell the y-intercept. So let's see if just figuring out those three help us narrow down what a zero is. So the vertex is going to be right around there. Looks like it's going to be 3, -7. X-intercept looks like I've got a 10 and a -4. So I'm going to say that's 10, and I'll also have a -4. And then y-intercept, oh, that looks like maybe -5.8. It's not exact. Okay, so that's a typical graph. Vertex, 2 x-intercepts, and 1 y-intercept. Let's do the same thing here. Vertex, x-intercept, y-intercept. Alright, so it looks like I've got 4, 0 is going to be my vertex. My x-intercept, that's where it crosses the x-axis. And I guess it's just right there. It's that 1. It's that 4. It touches, it just kind of reaches down and touches that x-axis, but it doesn't really cross anywhere else. And then the y-intercept, you can tell that this parabola is eventually going to grab that. I'm just going to put 15-ish, but we know that it has a y-intercept. Okay, so let's check our C. And we get the vertex of 0, 6. We've got an x-intercept at, looks like it's not quite at 4, so maybe -4.2 and a 4.2. So 2 x-intercepts. And then y-intercept is, since the vertex is right 0, -6, then it's going to be that -6. Alright, and then finally, let's check out D, and then we'll see if we can find a pattern there to figure out what that term 0 means. Vertex looks like it's got 2, 1. It's going to be my coordinate pair. I'm not saying any x-intercepts there. Yeah, it never even touches it. The minimum value is 1, so none. And then y-intercept, kind of tough. We'll just call it 5. Okay, so I'm looking for a 0. Well, every single one of these axes has a vertex, or these quadratic functions have a vertex. So that's not going to be what I'm looking for. Every single one of these has a y-intercept, which is just 1. So that's not what I'm looking for. So by process of elimination, we can tell that the 0 is referring to the x-intercept. In this case, we are looking for 1 x-intercept. If it's more than 1, it's x-intercepts. They are also called solutions. So x-intercepts have 2 different other names, solutions and zeros. And which one has only 1? It's this one right here. Because the vertex, the minimum value, is right on the x-axis. It's only going to cross one time, and our answer is B.